Beneath the serene landscape, a discovery changed how humans understood Earth's interior. There were no explosions, no panic. But deep below, something long hidden became visible for the first time. Not through conjecture or simulations, but through direct observation, revealing one of the world's most complex volcanic systems. That day, the journal Nature published research by Brandon Schmann's team. Using modern seismic imaging technology, they penetrated 3.8 kilometers beneath Yellowstone. Seismic waves acted as a giant scanner, revealing structures previously only speculated about. For the first time, a clear picture began to emerge. What they discovered was not the empty magma chamber often imagined. Beneath it lay a complex layer that served as a lid to the magma chamber. This structure consisted of a mixture of solid rock and partially molten material. It acted as a natural barrier, resisting the immense pressure that continually pushed up from within the earth. For years, scientists' attention has focused primarily on the volume of magma stored beneath Yellowstone, but this discovery shifted that understanding. Now, the focus is not only on its contents but also on the cap that maintains the system's equilibrium, because in many cases, this layer determines whether the pressure below the surface is stable. The magma cap is not a rigid, unchanging structure. It is constantly subjected to pressure, heating, and interaction with the surrounding hot fluids. Over time, this cap can weaken, crack, or otherwise change its properties. And in a system as large as Yellowstone, even small changes can have far-reaching consequences. Time passed, and attention to Yellowstone persisted. 3 months after the publication, the source of information shifted from the depths of the Earth to space orbit. Satellites began recording something previously invisible, a slow but consistent change. In July 2026, the Sentinel, one satellite detected uplift in the northern part of the caldera. This location is in the Norris Geyser Basin, one of the most geothermally active areas. Over the course of 6 months, the land in the area rose by about 2 centimeters. To the naked eye, this figure may seem insignificant, but in geology, small changes like this are significant signals. The uplift indicates increasing pressure beneath the surface. This pressure could come from magma, hot steam, or fluids moving within the system. What makes this phenomenon even more intriguing is its history. The Norris Geyser Basin last experienced a similar pattern in 2004. After that, the area remained relatively stable for more than 2 decades. Now, after a period of relative calm, signs of activity are slowly reappearing. In volcanology, recurring patterns are often key to understanding major changes. When an area becomes active again after a long period of quiescence, scientists begin to connect it to deeper processes. Is this just a simple fluctuation or part of a broader dynamic? When this surface deformation data is linked to previous discoveries of the magma cap, a more complex picture emerges. Changes on the surface could reflect increasing pressure at depth. A system that previously appeared stable may be adjusting to internal changes. However, there is no indication that a major eruption is imminent. Yellowstone remains under close monitoring. Scientists emphasize that the system is highly complex and cannot be concluded from a single indicator. However, any changes remain an important part of the bigger picture. Now, with data coming from both directions, from within the Earth and from space, our understanding of Yellowstone is beginning to evolve. This system is not a static entity, but rather something alive and constantly in motion. And if these changes continue, the question gradually shifts. It is no longer whether something will happen, but when the system will exhibit more noticeable changes.